Hi guys, in this video we're going to be looking at the rate constant, K, the effect of temperature on K, how does the rate constant change, the Arrhenius equation, Arrhenius plots, and finally we'll summarise.
So we're going to be talking a lot today about the rate constant, K, which we've met before. So let's look back to the rate equation. So the rate of a reaction, which is the rate at which the product builds up or the reactants are used up, is equal to the rate constant times by the concentrations of the reactants. So we've looked in detail at how the concentration affects the rate, but what about the rate constant? How is the rate constant related to the rate? Well, if the concentrations are constant, then the rate is just directly proportional to the rate constant. So the larger the rate constant, the higher the rate. So if we look back at some first order rate concentration graphs, which you should recognise from a previous video, you should know that the gradient of these graphs is equal to the rate constant. So we can see here the graph on the left has a low rate constant and the graph on the right has a high rate constant. When all of the concentrations of the reactants are kept constant, so if we look back at the equation, any changes in the rate constant will be the same as the changes in the rate. The rate constant is therefore a good measure of the rate in these circumstances. Now we've looked back at how the rate constant is related to the rate, it's now time to think about the effect of temperature on both the rate and the rate constant. So temperature gives a measure of the amount of energy that the molecules have. So if we look at this picture below, the picture on the left shows a low temperature situation. The small arrows show that the blue particles have less kinetic energy and move less quickly. The red particles have more kinetic energy and move more quickly. So the point about a low temperature situation is that we have fewer molecules that have a high energy. Whereas in the picture on the right, where we have a high temperature, we have far more of the red molecules with the high kinetic energy. The point about high temperatures is there are more high energy molecules. To start thinking about how the temperature affects the rate of reaction, we're going to look back at some of the work you'll have covered last year on Boltzmann distributions. You should be familiar with the activation energy, the minimum energy a particle needs to react. So only particles with energies over the activation energy can react. So let's label that on our diagram. So on the x-axis we have the energy of the particles, and on the y-axis we have the number of particles that have this energy. And then this line shows the distribution of the energies. In purple we've labelled on the activation energy.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the Snap Revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.